We know that in order to write the equation of a line, we need both the slope of the line and a point on the line. And we learned how to use the slope formula to find the slope of the line when we had 2 points. We also know how to use the slope-intercept form of the equation to find the slope. But in this video, we're going to look at parallel and perpendicular lines. And we'll see that there is a relationship with their slopes that is going to give us yet another way to potentially find the slope of a line whose equation we're trying to write. So let's start by talking about parallel lines. Two non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. So the key here is that parallel lines have equal slopes, but they have different y-intercepts. Why is it necessary to say they have a different y-intercept? Well, if they don't, they would be the same line and not parallel lines. So the key for finding slope is that parallel lines have slopes that are equal. So let's look at an example where we're using this information to be able to write the equation of a line. So find an equation for the line that contains the point 2, -3, and is parallel to the line 2x plus y is equal to 6. Well, the first thing I recognize here is that I have been asked to find the equation of a line, so I'm automatically thinking, okay, I need a point and I need the slope. I was given a point of 2, -3, but I wasn't actually given the slope. What I was told is that the line is parallel to 2x plus y equals 6. So if I can find the slope of this line, then I know my line has an equal slope because parallel lines have equal slopes. So how do we find the slope if we're given the equation? Well, we write it in slope-intercept form, and then we can look for the coefficient of x. So I'm going to take 2x plus y is equal to 6. I'm going to solve it for y, so I'm going to subtract 2x from both sides. So I get y is equal to 6 minus 2x. And now, since y is by itself, it's solved for y, so I can find the slope by looking at the variable or the coefficient of the x term. Now again, be careful, don't look just here, always look for x, and the coefficient of x is the slope. So the slope of this line is -2, and since my line is parallel, that tells me that the slope of my line is also going to be -2. So I can use a slope of -2 and the point 2, -3, and I can plug them into the point slope form of the equation of a line to find an equation for this particular line. So remember, in point slope form, y is y minus y1 is the y value from the point we were given. So -3 is equal to m is our slope of -2 times quantity x minus, remember x is x, x1 is the x value from the point. Y minus a -3 can be simplified into y plus 3. And then we have -2 times x minus 2. Now, you'll notice that the directions did not specify what form I had to give my answer in. So I can technically stop here, and this would be the point slope form of this equation. If it had specified to give it in slope-intercept form, then I would have kept going and solved for y. But since it didn't specify, we're going to go ahead and stop here. No reason to do more work than we have to. And that is how we find the equation when we are given a line that is parallel. Now, just like parallel lines have slopes that share some type of relationship, Perpendicular lines also have slopes that share a relationship. However, that relationship is slightly different. So for parallel lines, the slopes were equal. For perpendicular lines, the slopes are actually have a product of -1, or that is that the slopes are opposite reciprocals. So remember that a reciprocal just means flip the number upside down. So if it's 1/2, it would become 2/1. If it's 2/1, it would become 1/2. And then opposite means change the sign. So if it starts positive, we make it negative. If it starts negative, we make it positive. So now that we know that perpendicular lines have slopes that are opposite reciprocals, we can write an equation using this information. So find an equation of the line that contains the point 1, -2, and is perpendicular to the line x plus 3y equals 6. So our first step is to solve the equation we were given for y so we can find its slope. So subtract x from both sides. We get 3y equals 6 minus x. Divide both sides by 3. And again, don't forget to divide both terms on the right. So I get y is equal to 2 minus 1/3 x. Because remember, the x has a coefficient of 1 in front of it, so we get -1/3. So the slope of this line is -1/3, because that's the coefficient of x. And my line is perpendicular to that, so it means that I'm going to find the opposite reciprocal of this to find the slope of my line. Well, the reciprocal of 1/3 would be 3/1. And the opposite of a negative would be a positive, so my slope is a positive 3/1, or just 3. So now that I have the slope and a point, I'm ready to plug it into the point slope form. So y minus y1 is equal to m times x minus x1. So y is y is y never changes, minus y1 is -2, times m is 3, times x is x is x is x, x never changes, minus x1 is 1, simplify y minus -2 to get y plus 2. And again, it did not specify what form we had to give our answer in, so we can stop with point slope form. If it had specified slope intercept form, we would have kept going and solved for y.